Okay, in this example, we're going to be looking at solving simultaneous inequalities. We have a quadratic inequality, 2x squared plus 7x is less than or equal to 15, and a linear inequality, 7 minus 4x is less than 19. We're going to solve each inequality separately, and then we're going to use a number line to see which region is satisfied by both inequalities. So with the quadratic inequality, let's subtract 15 from both sides. That gives us 2x squared plus 7x minus 15 is less than or equal to 0. This one factorises to give us x plus 5 and 2x minus 3. And that means that the critical values are at x equals negative 5 and x equals 3 over 2. Let's sketch a graph to help us identify the region. We want the region where the quadratic is less than 0. So we want the region in between, which is minus 5 is less than or equal to x, is less than or equal to 3 over 2. We'll come back to that region later. Next, we'll solve the linear inequality. 7 minus 4x is less than 19. Let's add 4x to both sides and subtract 19 from both sides. That will give us 4x on the right hand side. 7 minus 19 is negative 12. Dividing through by 4 gives us x is bigger than negative 3. To find the region that satisfies both inequalities, we need to draw a number line. First of all, we want negative 5 and 3 over 2 on the number line. And as it's not a strict inequality, it can be equal to these two values. We're going to draw two filled in circles above. For the second inequality, we've got x is bigger than minus 3. So we'll put minus 3 on our number line. And it's a strict inequality, so we're going to have an open circle above negative 3. And it's bigger than negative 3, so we want a line going to the right. Now that we've got our diagram, we want to find the region that satisfies both inequalities. So it has to be both bigger than negative 3, but also in between these two values. So that means it cannot be bigger than 3 over 2. So the region we want are the values that are bigger than negative 3, but less than or equal to 3 over 2. Okay, here's a problem for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution then. If you got it right, well done. This is a tough problem to attempt early on in the course. If you didn't, don't worry, I'll go through my solution now. We'll begin by solving the quadratic inequality. I want to make the right hand side 0. So I've got 2y squared. I need to subtract 13y from both sides. So I've got minus 13y. And I need to subtract 7 from both sides. This will factorise. We get y minus 7 and 2y plus 1. That gives us critical values at x equals 7 and x equals negative 1/2. Let's sketch the graph. We want the region where the quadratic is bigger than 0. So the solutions are x is bigger than 7 or x is less than negative 1/2. Let's solve the linear inequality. We have 1/4 y plus 9 is greater than or equal to 7. Let's subtract 9 from both sides. That will give us 1/4 y is bigger than or equal to negative 2. And then multiplying both sides by 4 gives us y is bigger than or equal to negative 8. Like in the example, let's draw a number line. We'll start with the quadratic inequalities. So we have a mark at negative 1/2 and a mark at 7. These are both strict inequalities, so we want open circles. And we want to the left of negative a half, and to the right of 7. Our second inequality is y is bigger than or equal to negative 8, so we'll mark negative 8 on the number line. It's not a strict inequality, so we want a filled in circle. And we want an arrow going to the right. So the region we want must be both bigger than or equal to negative 8, but it also must be less than negative a half. So our answer is minus 8 is less than or equal to y is less than negative 1/2.